Hi, this is COMP1010 at the University of Manitoba. I'm Dr. Celine Latulip, and in this video I'm going to be talking to you more about arrays. How do you compare arrays? How do you swap elements inside of an array? And I'm going to be going through a big example of using arrays for a deck of playing cards. So let's start with comparing arrays. Imagine when you have two different arrays, and from the machine's perspective, if you want to compare two arrays, what you really want to know is, are the elements that are inside the array different? And from a human perspective, if these green rectangles weren't here covering up what was in these arrays, you and I can look at this and just say, yeah, they're the same, or no, they're not the same. But a machine can't just do that at a glance type of comparison. A machine has to do things methodically. And so we need to have the machine look at each element individually. Now, you might think that you can compare arrays by doing something like testing, does A1 equal to A2? And that will only compare reference values. So if you have two separate arrays, this isn't going to work. If you have two reference variables that are both pointing at the same array, then this would return true. And that means you have one array and both of the reference variables are pointing at them. But probably what you have is two separate arrays, and you want to know if what's in those two different arrays is the same. So this won't work for that. So it's the same thing with strings. That's why we can't compare strings using equals equals. We actually have to use the string dot equals function. So if we want to know whether or not two arrays actually have the same contents, we've got to do something different. So this is a function that will do this kind of check for us, and we're going to walk through it here. So if two arrays, whether or not they're the same or different, is a sort of a Boolean thing. It's either true or false. They either are the same, in which case it's true, or they're not, in which case it's false. So in order to do this comparison, we're going to return a Boolean. We're going to pass in two arrays. So this function allows us to compare integer arrays. So we've got an integer array and another integer array. We're calling one A1 and we're calling one A2. Now, we will know immediately that two arrays are not the same if they don't have the same length. So if A1 has 4 elements and A2 has 100 elements, well, those two arrays are obviously not the same. So the very first check that you want to do in this situation is to make sure that the lengths are actually the same. And what we're doing here is we have an if statement that checks that the lengths are not the same. So if A1.length does not equal A2.length, and then we return false. So this actually jumps us right out of the function. We stop, we don't execute anything below here. We've returned false to say that no, they're not the same. Then we have, if that doesn't happen, then A1.length must equal A2.length for us to even get to this line of code here. And in that case, we're going to do this for loop. We're going to loop from 0 up to, but not including the length of the array, and incrementing by 1. So we're looping through each element of the array, and we're looking to see if the element in A1 is the same as the element in A2. And in here, actually, what we're looking to see is, are they not? Because we want to stop. As soon as we find two elements in the two arrays that differ, then we're kind of done. All it needs is for two elements in the two arrays to be different, for the two arrays to be different. So as soon as we find that there's an element in A1 at a specific index that is not the same as the element in A2 at that same index, then we found a difference. And again, we are going to return false. And we're going to jump out of this whole function and say, no, these two arrays are not the same. If we get through this entire for loop here, then we haven't returned false, then that means that the two arrays are the same length and every pair of elements that we compared were the same. And in this case, then we return true. Okay, so this is one way to do this, and it works fine. The problem with the way this function is written is that we've actually got 3 return statements in this. And if you'll remember from our discussion of writing functions, it's really typically better to only have one return statement at the bottom of a function. So let's see if we can rewrite this. And just to clarify, we could now use this function and we could call it by saying something like if equals, and we could pass in 2 int arrays. And this would do that comparison. And if it was true, then we do something. And if it was false, we do the else part of this if. Okay. And this is very similar to what we do with strings, but with strings, we do string 1 dot equals string 2. So it's a different syntax on strings. Okay, so here's the alternate version of this function that only has one return statement. So the way that we typically write these functions is we create a Boolean variable at the top of the function and we set it to either true or false to begin with. So here we're going to set it to true. We're going to assume that the two arrays that are passed in are the same until we find out different. And so we have this Boolean variable called equal. Now, the first thing we do again is we test the length. And if it turns out that the lengths are different, then we change equal and we set it to false, okay? Now, if that's true, if the two arrays are different lengths, we don't actually want to do this for loop, but we haven't got a return statement here. We're not popping out, so we need a way to skip over this for loop. And so what we're doing here is in the second part of the for loop header, we are actually putting in an extra thing. So remember that this initializes our counter and this says this is the conditions for continuing. So we want to continue while our counter is less than the length of the array, but we also want to continue while equal is true. And if we've set equal to false here, then we will never actually execute this for loop. So this is a slightly different syntax than you've seen before for a for loop because we've added an extra condition in here in the part of the for loop that says our continuing condition. So if we come in here and a1.length is equal to a2.length, so this doesn't execute and equal stays true, then we're going to come in and we're going to execute our for loop as before. Again, we're going to do pairwise comparison of the same index in the two arrays. And if ever the elements at that same index in the two arrays is different, they are not equal, then again, we're going to set equal to false. And that will actually, again, cause us to then jump out of this for loop because we'll come up here and equal will no longer be true. So that will, again, get us out of our for loop early if we find a difference early. And then at the very bottom of this method, we return equal. So equal will either be true if none of these things happened, or if any of these things happened, it will be set to false and we'll be returning the right value. And again, we call this using equals. Okay. So next I want to go over the idea of swapping two numbers. And we've talked about this before with integers. So let's look at what this looks like with integers just to refresh. If we have these two values, a is 7 and b is 5, and we want to swap them so that a is 5 and b is 7, what you typically might think you could do is just do something like this. Assign b to a and then assign a to b. The problem with this is that as soon as you do this first statement, we've now got a and b both being 5, and we've lost the 7. And then the second statement just sets 5 to 5, which does nothing. So the right way to swap values is to use a third temporary variable to save the value that we're overwriting in the first case. So in this case, we're going to say save gets assigned a. So now save gets assigned the 7. A is 7 and b is 5. The second statement, we assign b to a. So now save is still 7, a is 5 and b is 5. And then in the third statement, we assign b to the value that we saved. And so now b is going to be 7 and a is 5. And so this achieves our swap. So there's just this idea of having a temporary variable and then moving the variables around between these three different things. And the point of going over this again is just to show you that the exact same thing happens with an array. So here we're going to, if we have arrays and we're trying to get the value in the array at x and swap it for the value in the array at index y, then what we have to do is get the value out of the array that's at x, put it into save, then get the value out of the array at index y and put it into the array at index x, and then we grab our value that we saved here and save, and we put it into the array at index y. So this is how we swap values in an array, again, using a temporary variable to store one of those values. All right, so now what we want to do is go through an example, which is a deck of cards example. And deck of cards is really great because With card games, you need to be able to store a deck, 52 items, you need to be able to shuffle it and display it, and so arrays are a good way to do this. You could also imagine using arrays to store the cards in an individual player's hand if you were actually playing a game. For right now, we're just going to look at the basics. How do you create a deck of cards? How do you shuffle them and display them? And so what we're going to do is we're going to use an array of integers that's going to have 52 elements in it. And that's going to store the integers 0 to 51. So every card in the deck of cards is going to be represented by one of these numbers. So you can think of 0 as representing the ace of spades and 51 as representing the king of clubs. And all the cards are represented by one of these numbers. So all the cards from one suit are followed by all the cards from the next suit, etc. And we can use integer division. We can get a card, and it's going to be an integer between 0 and 51, and we can divide it by 13 doing integer division, and that will give us the numbers 0, 1, 2, or 3, because 51 divided by 13 would give us 3. That's the biggest number we'd have. 0 divided by 13 would give us 0. So this means this gives us sort of these numbers, which we are going to use to represent the 4 suits in cards. So if we have a 0, that's spades, 1 is hearts, 2 is diamonds, 3 is clubs. We can use card mod 13 to get a rank. So remember, if we're modding something by 13, we'll get numbers from 0 up to 12, and then we'll use that as an index into an array. And so we'll store this array, which is our characters that represent the rank. So we have ace, 2, 3, 4, 5, 6, 7, 8, 9, T for 10, J for jack, Q for queen, K for king. Okay, and so by using these numbers as an index into this array, we can get a representation for each card of what card it actually is. All right, so now we actually need to create some functions. So if we want to create a new deck of cards, we're going to have a function that will do that. We'll call it new deck, and it's going to return an array of integers. And if we want to get the rank of a card, we want to be able to pass in an integer from 0 to 51 and have it return a character that could be A, or it could be the character 2 or 7 or T or J or Q or K. And so we're going to pass in an int, and we're going to get a char out. We want to be able to get the suit of a card, so we want to again be able to pass in one of the cards, the ints from 0 to 51, and have it return an int from 0 to 3, which will represent hearts, spades, clubs, etc. And then we want to be able to shuffle the deck of cards. So we want to be able to give the function shuffle a deck, which is going to be an array of integers, and have it do a whole bunch of swaps, which is why we just reviewed swaps, to mix the cards up so that they aren't in order from 0 to 51 inside of our array any longer. And then we want to be able to display the deck of cards on canvas, and we need a method to draw an individual card. So our display deck is just going to iterate through the 51 cards in the deck, or the 52 cards in the deck, and for each of those cards we're going to call display card. We're going to say which card it is, so we'll pass in the number of the card and then where to display it on the canvas. Okay, so how is this going to work? Once we create a new deck of cards, we're going to have a new deck. It's going to be an array, and it's going to have these values in it. I'm not showing all of them because it's a lot, but these are going to be cards in order from 0 up to 51. If we want to get the rank of a card, we're going to pass it in as an int. So we might do something like char rank. So this is going to store the rank. We're going to call get rank. We're going to pass in our array with an index. So what this is really doing is it's saying go to the array, get whatever number is at 23, and pass it to get rank. So get rank actually takes an integer. So in our current deck, at index 23, we have the number 23. 23 mod 13 is 10, and then we use 10 to index into that char array, and so this would return J. So we can do this with any card, and it will return, either A for ace or one of these other values. We want to be able to get the suit of a card, so if we do the same thing, we call get suit, we're going to store the return value in an integer called suit. We're going to pass in an integer, so here we're saying go into our integer array, new deck, get whatever's at index 23. Again, because the deck hasn't been shuffled, this is going to get 23. And 23 divided by 13 in integer division is going to give us hearts. So this is going to be the Jack of Hearts. What's at 23? Now we also need to be able to shuffle the deck. So if we shuffle the deck, our array might end up looking like this. So again, it's got the same number of elements in it, but they're all mixed up now. And then we can call get rank or get suit and it'll be different. So now if we do char rank and we call get rank and we do new deck of 3, new deck of 3 is 0, 1, 2, 3, that's 20. So we're going to pass 20 into get rank. 20 mod 13 is 7. We'll use 7 to index into our rank array, and this is going to return 8. So this card is an 8 of something. Okay, so that's basically sort of how it will work, and we want to now look at the actual code. And that's the same thing. So let's switch over and look at our code. So here's the code, and I'm going to zoom this in. Make this bigger so that you can see it. Okay, so here's the code. We have our final int, our deck size, this is the number of cards, is 52. And we have finals that we're using to store the different suits. So spades is 0, hearts is 1, diamonds is 2, and clubs is 3. So these are constant ints. And then we have some stuff here for actually displaying. So how big the cards are, how the spacing, the number of cards per row when we display it. And here we have a variable, which is an integer array variable, which is called the deck. And we're going to create it by calling new deck, which is a function that we've written that will actually create and put the values into this. We have a setup function. The setup just creates a canvas and then calls display deck. So we'll see what that looks like later. Our draw method at this point does nothing. There's no animation happening. And when we call mouse clicked, we're going to call our shuffle method. We're going to pass it the deck. So it's going to actually swap a bunch of values to shuffle up the deck. And then we're going to call display deck again to update the display on the canvas. So here's our new deck method. So we have our int deck, or we're going to create an integer array. We're going to call it deck. And that's the statement here to declare the reference variable and create the array. And then we loop through the array. And what we're doing here is the first card in the deck is going to be 0. So we're just assigning I to the element. The second card is going to be 1. So deck of 1 will be 1. Deck of 2 will be 2, etc. This gives us an initial deck that is not shuffled. It's all in order. Okay. And then we return this deck. And here's our shuffle method. And so what the shuffle method is doing is it's going through a for loop from 0 up to the deck length -1. So we're not going to shuffle the last 2 cards. We're going to stop before that, iterating across, and then we're swapping cards. So we get a swap card. So this is saving the value. And we're starting with next card, and then we're going from there and adding a random number so that we're getting a card that's somewhere in the deck, okay? So swap card is just the index for the card that we're going to swap our current card with. So then our saved card becomes deck of next card, and then next card becomes the deck of the swap card, and then the deck of the swap card gets our save card. So these 3 lines here are doing the swap. And so we just go through and we do this and we just keep swapping cards throughout the whole deck. Now, then we have a display method, which is going to go through and put the cards on the screen. So this is looping across the entire deck and we're drawing them out. And there's some stuff here that's moving us down to the next row so that we're going to draw these cards in a grid. And I'm not going to go over that in detail. And each time we actually then call display card, so we know what card we're drawing, so we're getting the number out of our deck and telling it where to draw it. And the display card is actually going to go and get the suit and the rank and draw a bunch of things, and we're drawing the card values. So again, I'm not going to go through the details here of how the cards are drawn. You can look at this code yourself. But here's our rank that gets us the character rank for a number and returns that. So let's play this and then we'll see what it looks like. So when we run this, here's our deck of cards and it's all in order. We're starting with spades and then hearts and then diamonds and then clubs. And if I click anywhere, the deck gets shuffled and then we're going through and we're displaying the new shuffled deck. And if I click again, it'll get shuffled again. So you can have a look at this code. It's a really good example of how different arrays can be used to store cards. All right, that's it. Thanks.